It looks like a giant aircraft hangar. But inside, no engines, no jets, just a massive circular room thick with the echo of turbines and the hush of anticipation. Suddenly, a switch is flipped. A deep, thunderous hum builds. Air starts to move. Slowly at first, then faster. Faster still until you're standing in a storm, inside a machine. You've just stepped into a wind tunnel, one of science's greatest yet least understood inventions. And behind its metal walls, some of the world's fastest machines, safest planes, and sleekest cars are put to the test. What even is a wind tunnel? A wind tunnel is exactly what it sounds like, a controlled tunnel of high-speed air. But it's not just wind for wind's sake. It's about simulating real-world conditions, but without actually leaving the ground. In the tunnel, scientists place scaled-down models or even full-size vehicles, planes, cars, bikes, buildings, then shoot air over them at high velocity. It pushes, pulls, drags, lifts. And in design, understanding how something cuts through the air aerodynamics can mean the difference between flying or crashing, winning or losing, stability or disaster. How it works. A river of air. At its core, a wind tunnel works like this. Massive fans or turbines generate wind speeds from a gentle breeze to hurricane force. The air passes through flow straighteners to make it move in clean, even layers, no turbulence, no chaos. The test object is placed in the test section, surrounded by sensors, cameras, and sometimes even fog or smoke streams to visualize flow. Every second, data is captured: pressure, lift, drag, and flow separation. In closed-loop wind tunnels, the air is recycled continuously. It circles like a racetrack, saving energy and maintaining temperature and humidity. And yes, NASA, Formula One teams, aerospace engineers, and even architects use these tunnels to test everything from Mars rovers to Olympic suits. The human side. First time in a tunnel. When I first stepped inside a wind tunnel during a tour of the Langley Research Center, I was stunned by the silence. Not the literal sound, but the mental quiet. There's something sacred about standing in the place where failure is simulated, recorded, and learned from again and again. The engineer guiding us showed a scale model of an aircraft with fine black smoke trailing from hundreds of tiny holes in the surface. When the fans roared to life, the smoke clung to the wings until it suddenly peeled away near the tail. "See that?" he said. "That's the stall line. This plane would lose lift at that angle." He wasn't guessing. He knew because the wind had spoken. From fighter